Hi, I'm Dave Leo from Kaiser Institute of Health, and I'm talking today about the dangers of blue light. Now, light comes in many shapes and forms, and particularly if we look at natural light from the sun, what you'll see is there is a wide spectrum. And what we mean by wide spectrum is there's a range of different colors. We've got our reds, our orange, our yellows, our greens, our blues, and our indigos through here and our violets. So that's what normal sunlight looks like. Now, if we compare that to artificial light, you can see there's quite a different pattern here. So an incandescent, which is the old school light bulb, now that has actually quite low in blue, but higher at this end. Now, more modern lighting is a lot more problematic, unfortunately, because when we look at LED lighting and fluorescent bulbs, you'll see here it's very much loaded with a lot of violets and blues and greens. And that's where we're getting our problems. So in particular, we are getting bombarded with artificial light in what we call short wavelength here, and this violet and blue. That's the main one that's giving us problems. Now, particularly if you're looking at screens such as phones, tablets, computers, very high in violet and blue. Now, why is this a problem? Well, because the way that the brain's set up is that blue light, we're designed to see that in sunlight. We're not designed to see it at daylight and dark, sorry. So when your brain sees that, it gives us a very different reaction. Now, what can happen is exposure to those short wavelength light there, that can cause phase shifting where our body thinks it's a different time of day than what it is from being exposed to blue light, which is supposed to be daylight. And also, it can change melatonin. And melatonin is our sleep hormone, and that's the one that helps us repair and recover. And if you're not repairing and recovering, it doesn't matter how well you're exercising or eating, you're going to get yourself in trouble. So this graph down here, we've got melatonin on the side here, and you can see this is what happens to melatonin production over time. So when it becomes dark, melatonin production increases, as you can see here. But what we've got here is we've got one group here exposed to light, and 150 lux is around an office lighting, pretty decent office lighting. Now, the group here, and this is children on this side here, as soon as they hit that light in around 11 p.m. here, you can see their melatonin plummets here, and that's an issue. In adults, we have the same issue here as well. That melatonin plummets as well, but not quite so much. We get used to having disruption. Saying that, though, we can get disruptions of 10 to 15% in daily melatonin production by being exposed to light at night. And we can get a 70% reduction in melatonin. It's pretty common from being exposed to light prior to sleeping. Now, what should we avoid in terms of light? Now, particularly the violet and blue, this 380 to 495 nanometer range, has a very strong effect on melatonin, and that's the big one that causes us problems. Green has a smaller effect. Now, you'll see that green goes from about 500 to 570 nanometers. Anything higher than that doesn't seem to have much of an effect on melatonin. And that's important when we talk about blocking blue light later on. Now, disrupting melatonin, particularly by being exposed to light there prior to sleep or during the dark, will give you all sorts of problems in terms of repair and maintenance of the body. Now, melatonin is also a strong antioxidant. So in terms of anti-aging and clearing up free radicals and looking after your cells, that's an important one as well. Melatonin also improves mitochondrial function. Now, mitochondria are the energy factories inside every single cell. So if your mitochondria aren't operating well, you're not operating well. So is all blue light bad? Well, it can't be, because you remember in that first slide there, we showed that blue light was part of the natural light spectrum. So if it wasn't supposed to be there, it wouldn't be there. But it's supposed to be there in the day, and it's not supposed to be there all the time, because blue light actually damages the retina. Now, these RPE cells, which are retinal pigment epithelial cells, now they're right at the back of the retina, so the light shines through, and when blue light hits those, it actually damages and destroys them. Now, that happens all the time. So now the issue is, look, we need to have a bit of exposure to sunlight, otherwise it wouldn't be there. But around 30 minutes a day seems to be enough to get our circadian rhythm in the right place and have us operating and sleeping better. More than that, so if you're using blue light all day and off your computers and your tablets and your phones, that will damage your eyes. Now, at night, if you're continuing to doing that, that will damage your melatonin and your eyes. Double banger. So this is from Neurostem Cell, a quote directly out of their journal in 2016. Now, while these RPE cells, those retinal pigment epithelial cells, don't, what they do is they feed and they maintain the molecules that allow us to see, the photoreceptors. So the RPE cells, they don't initiate the reactions that make the visual process happen. They protect the molecules that allow it to happen. So they keep the cells that allow us to see in good condition. So when we damage the RPE cells too much, well, you're going to get diseases like macular degeneration, and if enough cumulative damage occurs, blindness. So this isn't a new phenomenon. In the 1960s, they were looking at blue light damage. Now, the only difference is now we're just getting so much more exposure to us. And I think what will happen in the future, particularly with our younger generation and even our high computer users today, we're going to see a lot more eye damage, unfortunately, due to this. So what do we do about this? We need to reduce light intensity and block blue light at night. So reducing screen time is an easy one, and dimming your lights down at night. We want to sleep in complete darkness as much as possible, and go back to using old school light bulbs can help as well, and potentially even red light bulbs can help, although it can make seeing kind of difficult at night, which makes getting around the house tricky. Now, installing filter apps on your computers and tablets and phones can be useful, although there's some debate on the effectiveness of this, because when you've got pixels, to make a certain color, you have to have pixels of different colors. So that can cause some issues. Now, another option is to look at blue blocking glasses, and blue blocking glasses look a little bit like this. And well, do they work, first of all? Now, this study here looks at your melatonin production at night, and we compare the CL, which is a clear lens, with a blue light filtering glasses here. As you can see here is when we're sitting in a regular room, a regular lounge, what happens here is you can see melatonin is much lower to rise in the clear lens groups, which means they're probably less sleepy, more alert before they go to bed. Now, unfortunately, it also means they have less melatonin to help with that antioxidant, helping those mitochondria and helping with repair. You can also see afterwards too, the clear lens group here, their melatonin hangs around, which means they're probably pretty likely to be drowsy during that whole morning period, right up till pretty much 9:45, halfway through the day. Now, compared to the blue light blocking glasses, where their melatonin comes down pretty steeply, so they wake up refreshed and alert. So yes, they do work. So what do we need to do ideally? Now, at least during the day, particularly if you're a heavy computer user, we would suggest actually blocking some of that 380 to 450 range in particular during the day. So some blue light blocking glasses will be very useful, particularly if you're in a high computer using environment. Now, at night, you want to be blocking up to at least 500. And that's if you want to protect your melatonin in particular, and help your sleep patterns, that would be a must for us. So how do you select blue light blocking glasses? Now, I've got several pairs here. This one here, if you compare these two here, you'll notice this one here is a lot more yellow. This is the darkest set of blue light blocking glasses that I got from a whole bunch of manufacturers. Most couldn't even tell me what transmission spectrum these glasses were. So in other words, what they were blocking. I suspect this one blocks maybe up to 420. These ones here we had designed for us. These lenses we got made for us in a lab. They block to 500 nanometers. We know that. Now, we also looked at 570, and those of you who've done a lot of reading may want to block green light as well, and that means you'll need to block to 570. Now, that's 570. These glasses here are quite dark even during the day. I tried using these at night, and I couldn't even get around my house. So these ones here at 500, and if you have a look through those are perfect for nighttime and for daytime use. Now, also, in terms of when you're looking at blue light blocking glasses, it's voluntary to have your glasses certified. So if they're not, the manufacturers don't have to have them done. They can choose to have them done. We got ours certified by the Australian New Zealand standards, by European standards, and by the American standards, and they block to UV 400. Now, I've probably had a dozen pairs of these through, and none of them had certification unless we actually got a lab to go and get them done and pay for them to have them done. So there's a difference as well. Now, in terms of using blue light glasses, never drive with them because it changes the color of your traffic lights and also makes kind of, it can change your perception a little bit as well. Now, the only ones that I've seen that are comparable to our glasses that we've had designed for us are Swannies in the US, and they run at $89 US, and they also block to 500 nanometers. Certainly, ours work beautifully. I can vouch for you that I can vouch for them. So if you're interested in glasses, please have a look at the Kaizen IH blue light blocking glasses.